Yeah, we're studying parallelograms, and as I just said, uh, this is a quadrilateral. Get a proper pen here. Yeah, that's better. All right, this is, or these are, a quadrilateral, with both pairs of opposite sides parallel. I know you're familiar with parallelograms. Maybe for a long time you've been. All right, but let's take a close look at this one. This side is parallel to this one. These are opposite sides, and also this side over here is parallel to this one. I'm going to come up with a number of properties based on a comparison between these two triangles. Now I'm going to compare this triangle here, GOL, with the lower triangle, GLD, and see what properties we can come up with. Campbell, pay attention. As I compare these two triangles, this one with this, very quickly, you can see a relationship between this angle, let me call it angle 1, and angle 2. Angle 2. Who can tell me what relationship there is between angles 2 and angle 1? We got parallel lines here. This could be a transversal. Campbell, can you tell?
Alternate interior angles.
Absolutely. These are going to be definitely congruent to each other, alternate interior angles. In addition, there's going to be a relationship between this angle here. I'll give this a double. Let's make this angle 3. And this one right here from the lower triangle. Let's make it angle 4. Angle 3 and angle 4 are also alternate interior angles, so they are congruent. And as I make the complete comparison between this triangle and this one, I can see that this side here, GL, is, who remembers the word? GL is? GL from this triangle is the same as GL from this one. Who remembers the word?
Congruent?
It's congruent, yes, they're congruent. All right, but it's reflexive, is it not?
Yeah.
It's reflexive. So this triangle is an identical twin to the lower one by, and here's good review for us, it's going to be side, 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 side angle, side, or angle, side, angle. Who can tell? Laura? Can you tell? I know my marks are not as nice as I'd like them to be. Can you tell? Is it going to be side, 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 angle, side, angle, or HL, or HA? We did some of those. Can you tell? All right. Anybody see it?
Angle, side.
We got angle, side, angle. Angle, side, angle. All right, that's what I was trying to make here. Let me see. All right, so the two triangles are identical twins by angle, side, angle. Therefore, please listen carefully now. I'm going to come up with some properties. Therefore, this angle here, angle D, I'm going to give this 3, it's going to be the same as what? This angle O is the same as angle D. 1, 2, 3. See if I can make this a little bit better. D here. Why would that be so? Can anybody remember why? Why would these angles have to be the same based on the fact that these triangles are identical twins? Remember, Dylan?
The other two identicals are congruent.
Any of you remember this? Let me write it. What remembers that? Maybe if I say it. CPCTC? Corresponding parts of congruent triangles are congruent. Remember that? These are matching parts of congruent triangles. So this angle matches with this one. It's got to be congruent because the two triangles are identical twins. All right, but anyway, I'm not doing proofs right now. I want to do a property with you, and the property is going to say that opposite angles of a parallelogram are congruent. So write that down. Opposite angles. You can do that. Of a parallelogram here's a symbol for parallelogram. Whenever you see this in books, it kind of looks like a tilted over square or rectangle like that. These are congruent. All right, that's my first property. So what that would mean is if I had another parallelogram here, let's say this is a parallelogram, it would mean that these angles would be the same, and also these would be the same. Right? All right, let's go after another property. As you look at these two triangles, these two angles would have to be the same. Are there any other matching parts which would have to be congruent to each other? Angle O and angle D are congruent. Any other matching parts would have to be equal to each other, since the two triangles are identical twins. What do you see it? All right, let me help you. DL would have to be the same as what? GO, they're matching parts. So 1, 2, 3, 1, 2, 3. In general, therefore, we can say that opposite sides of a parallelogram are congruent. Opposite sides of a parallelogram these are congruent. All right. So as we come here, we could actually mark, the opposite sides and so on, congruent. I want to give you another property. Maybe I could draw another one to show you. But let me deal with this one first. Take a look at this parallelogram right here. This is parallel to this. And now, let me just put some numbers in here to bear this out. Let's say this is 120 degrees. What would this angle have to be? Who can tell me? This is 120, then this would have to be what? It would be 60. So how do you know? Well, let me just do a little drawing here. If I consider this to be continued here, kind of like a transversal, and these are parallel lines cut by a transversal, and these two angles here, who remembers what they're called? This angle with this angle, angle B and angle C. Abby? Angle B and angle C, we studied that before.
Is it consecutive exterior?
They're supplementary. Consecutive interior angles are supplementary. So if this is 120, this would have to be 60 degrees. So in general, therefore, I'm going to say that the consecutive angles of a parallelogram are what? Supplementary. Write that down. Consecutive angles of a parallelogram are supplementary. And that means if you know one angle, then you're going to know the one which is consecutive with it. Let me illustrate like this. If this is 120, as I said, this is 60. And if this is 120, then this would have to be what? 60. So these would have to be the same. The opposite angles would have to be the same. And then the 120 here would predicate that this would have to also be 120 over here. All right. So that, then let me go away from that. Let me see. Opposites. Yeah, let's go away from that and see if we can pick up a few other properties. Not right there. Let me go to another parallelogram. Let's look at the rhombus. Any of you know what the plural of rhombus is? Rhombuses or rhombi? Yeah, rhombus is actually rhombi properly, but anyway. As I think about bone eyes, I think about rhombi. Okay. All right, rhombus is also a parallelogram. It definitely is, because you'd have this parallel to this, and this would be parallel to its opposite side like this. It's a kind of, it's almost like a square. The four sides are congruent for a rhombus. All right, it's a parallelogram with the four sides congruent, so it's somewhat like a square. But here's what I want to tell you about a rhombus. Let me just draw the diagonals. And go ahead and just draw a rhombus, and then I'll show you something. Diagonal, let me just draw them. I draw one diagonal like that. And you can do it also. You take the other diagonal. There's something quite interesting about the diagonals of parallelograms. They actually are perpendicular. They're perpendicular. In fact, let me do it for the square also. I'm going to use this for a square and draw the diagonal here, both of them. Right? So, all right. So, yes. So the diagonals of a rhombus, I'm going to give you a note on that. The diagonals of a rhombus they are perpendicular. Let me ask you this. Do you think every square would be a rhombus?
Yes.
Definitely, because every square has got four sides equal, right? Was that a guess?
Yeah, that's a yes.
Yeah.
No,
A rhombus is a parallelogram with four sides equal, so every square is a rhombus. But would every rhombus be a square?
No.
No, because a rhombus could have angles which are different than 90 degrees. A square has all 90-degree angles. So with a square, we would have the diagonals being perpendicular as well. You might say, well, isn't that true for all parallelograms? Not really, because take a rectangle. Let's say we have a rectangle here. If you look at the diagonals for a rectangle, you don't have to draw, you can just look at this one. See if I can. Yeah. All right, if I would draw, not like that. Let me try again. I would draw the diagonals for a rectangle. All right. Do you think these diagonals would be necessarily perpendicular? Well, maybe you can't see it like that, but especially, let me give you maybe an extreme case. Let's say we have a pretty skinny rectangle like that. And let's take a diagonal like that, and one like that. You think those would be perpendicular? Seriously?
No.
No. It's only when you've got a rhombus or a square when the diagonals are perpendicular. All right, let me give you one more word about the diagonal before we go to our worksheet. Let me go back. Oh, yeah, this is one I forgot this one. If we, probably not a good place, but if we draw another diagonal here, these diagonals would bisect each other. So GL would bisect OD, as well as OD would bisect GL. So what does that mean? Maybe I could illustrate it on a separate sheet. All right, let me go ahead and do it this way. Let's say we have a parallelogram. So it's almost like it's nervous. I'll just stay close to my laptop maybe to get it right. All right, let's say we have the diagonals like that. They're going to bisect each other. What does that mean? It means this. It means that this segment here is going to be the same length as this one, and this one over here is going to be the same as this. All right? So make a note that the diagonals of a parallelogram, they bisect each other. All right? I want to go ahead and go to a worksheet with you right now, and I think maybe I'll stop this here.